Now let's talk about continuity. This section is very connected with limits, so bring out your knowledge learned from the limit section and it should be an easy ride. Now, let's start with looking at these three different functions. You can probably easily tell from instinct that the function in graph A is continuous. But how? How do you mathematically prove it? What is the definition of continuous function? Well, if you are so eager to know, then we should bring out the information out immediately right now, shouldn't we? Since it's pretty easy to understand, I'll tell you the definition of continuity right now. The function f of x is continuous at point x equals c. If the limit of the function as x approaches c equals the function's value at point c itself. Notice that x equals c here needs to be an interior point. For the function to be continuous at its left and right endpoint, x equals a and b, the function's value at the endpoint only needs to be equal to the limit of the function as x approaches the endpoint from the direction that is approachable. You may take this time to take down this definition on your notebook. Remember to use the pause button. Now, if a point C did not reach these requirements, then the function is discontinuous at this point, and this point is the point of discontinuity. What about the function that is continuous at an interval and a completely continuous function? If f of x is continuous at every point in the interval, then f of x is continuous at this interval. And if f of x is continuous at every point of its domain, then this is a continuous function. It's super easy, huh? No, that was a huge information dump. How could you say that this is easy? I could not even understand it at all. Well, I see. If you are feeling difficult to understand, let us take an easy analogy. Let's imagine that you are drawing the graph of a function with a pen. A continuous function is a graph that you can draw in one go without lifting your pen. This is because the next point you will draw on the graph is always a point that your pen is reaching. Consider the next point your pen is reaching the limit of the function when x is approaching this value. Because the limit equals the actual value at that point, your pen always reaches the point that you need to draw so that you never need to lift it. However, in a discontinuous function, there is a point that your pen is not reaching but has to draw. Right here, you have to lift your pen in order to draw this point. This is the point of discontinuity. Connect the analogy of a pen with the definition of continuity. You'll figure it out very easily. Now, let us backtrack a bit and look at this property of the limits. Because a polynomial function is always continuous, that means the limit of a function as x approaches c equals f's value at c. You can see why this property works. It is literally just a rewording of the definition of continuity. Try to connect the idea of limits and continuity a little bit more. I will test you on this a little bit later. Now, let's look at different types of discontinuity. A type of discontinuity is actually removable. This happens when the discontinuity point on the function has a limit, but the limit simply doesn't exist the actual function value. You can change this function into a continuous one by setting the value at the discontinuity point to the limit of the function, just like how you can ignore this point, then draw the rest of the function without lifting your pen. The other type of discontinuities, however, are not removable. The first one is the jump discontinuity. In a jump discontinuity, only one-sided limits exist at the discontinuity point. You cannot change the function into a continuous one by removing a point. Because the limit is different from either side, your pen cannot go anywhere when you draw the function from a single direction. You have to leave your pen to continue drawing the function. There is also the infinite discontinuity, in which the limit does not exist for either side. This is because it reaches infinity. Your pen will keep going up without ever reaching a limit. It is obviously impossible to draw this without lifting your pen. Last but not least, there's the oscillating discontinuity, where the function oscillates infinitely at the point of discontinuity. The limit of the function here also does not exist. There are infinite amount of lines at the point of discontinuity, so it is literally impossible to draw. These are the 4 kinds of discontinuity. You can take notes, but you can also choose not to, because it's better to memorize it in your brain. Now let's take a look at the intermediate value theorem. This theorem is actually pretty obvious. It states that a function at a closed interval a to b will take on every single value between function of a and f of b. This means you can choose whatever value that is between a and b, and you can always find the point where the function equals its value. Because you have to draw this function without lifting your pen, you must have passed this point somewhere in between when raising the altitude from f of a to f of b. Now, we're almost to the end. Let's talk about, last but not least, the properties of continuous functions. If f and g are continuous at x equals c, the following combinations are also continuous at x equals c. However, I will let you guess what it is. Please guess using the properties of limits and write it down yourself. If you combine the property of limits and the definition of continuity, you can get one continuous combination of functions from each of the limit properties. You can pause the video here and try to write it down yourself. When you finish it, please unpause the video. Are you ready? Now, this is the answer. Did you get it right? If you got it right, congratulations! Notice that there is no power function variant because the inverse function will get discontinuous. If you are able to write this down yourself, then it proves that you have kind of mastered the ideas and concepts. Now let's wrap it up with the last rule. The composite rule states that if f of x is continuous at x equals c, and g of x is continuous at x equals f of c, then g of x is continuous at x equals c. Notice that g has to be continuous when x equals f of c, not x equals c. If you have memorized this, then congratulations, you have reached the end of video. You can take this concept back by memorizing the story of the dinosaurs and how to draw without lifting your pen. Thank you, and see you next time, if that's possible.